All right, so over the past 3 weeks, we have been working with solving a quadratic equation. We spent 1 week on factoring, where all problems were able to be solved by the factoring method of either using a greatest common factor, a difference of two perfect squares, or factoring our quadratic trinomial. We then spent an entire week on the square root method, in which we looked at that in the original quadratic equation that bx, the middle term, was missing. And then we spent an entire week on the quadratic formula. We focused on the discriminant and the discriminant predicting the number of solutions, and then using that to continue on to the full quadratic formula to find where the x-intercepts were located. This week, we are now going to be presented with a problem, and we're going to have to decide which method, factoring, square root, or quadratic formula, is the appropriate method. So looking at our first problem here, I see that it is already set equal to 0. And I see that it is a quadratic trinomial. And so I am going to very quickly see if this can factor. And so when I look at this, I might want to work off to the side here and say, well, I would know that x squared would have to be x times x. If it's a negative 14, I know that it is either a 1 and a negative 14, a negative 1 and a 14, a 2 and a negative 7, or a negative 2 and a 7. And I can look at this and say, well, I need to make a negative 5, and so this is going to be the correct combination. And so this is going to be our plus 2, and this is going to be our minus 7. So that when we finish out our steps in here, this would combine to that negative 5x that we need. So our factors would be x plus 2 and x minus 7. And so since we have determined that this could factor, remember our first step is to factor, which we just did here. And then our second step is to use that zero product property. And we're going to set up two equations and then solve those two equations. So we're going to have x equals negative 2 and x is equal to 7. And so what that would mean is that we would have an intercept at negative 2, 0 and at 7, 0. And so that if we were asked to sketch this, we would go to negative 2, 0 and 7, 0. Since our coefficient was a positive 1, this would open up. And now we won't sketch all those, but just wanted to give you a really quick review. All right, so when I look at this problem here, I immediately notice that this is missing that bx term. And if it's missing that bx term, then what that should tell me is that I'm going to use the square root method. And so the first step in the square root method is to isolate the square. And so I'm going to come over here, and my first step is going to be then to subtract 15 to move that. And I'm going to get 3x squared equals negative 5. And then I have that 3, so I'm going to have to take and divide by 3, and I'm going to get x squared equals negative 5/3. After I isolate this, I know that my next thing is to square root both sides. But what happens when I go to square root here is I'm square rooting a negative. And so that tells me that there is no real x-intercepts. There are no solutions to this. It never crosses over the x-axis. All right, so the next problem is x squared minus 36 equals 0. And you can see that I wrote it down twice here, and I meant to do that. So I want us to look at this because you'll see that some people might start to view these problems differently. Someone might look at this and say, I immediately recognize this as a factoring problem because it is the difference of two perfect squares. And say that, well, x squared minus 36 factors into x plus 6 and x minus 6. And then use the zero product property to set up our two equations. And then we'll get x is equal to negative 6 and x equals positive 6. And so that would tell me that we have an x-intercept at negative 6, 0, and an x-intercept at 6, 0. Now, someone else might look at this original problem and say, hey, it's missing that bx term. And so I'm going to use the square root method. I'm going to isolate the square and then I'm going to square root both sides. And when I do, I get positive or negative 6, which notice is the exact same answers that I got by using the factoring method. Okay, so there might be certain problems in which it's going to be a judgment call as to which method that you want to use. Okay, if I look at this one, x squared plus 9x plus 15, if I think about this first, I would immediately try factoring. But if I look at 15, I know that the factors of 15 are 1 and 15 and 3 and 5. And I need to make a 9x. And I know I'm not going to be able to make a 9x with these factors. And so that tells me I'm not going to be able to use factoring for this particular problem. Now, you might think, well, hey, can I square root this? But if I look at it, it has a middle term. It has a 9x. So I cannot use the square root method. So that means I am going to have to use the quadratic formula. And if I'm going to use the quadratic formula, the first thing that I'm going to start with is the discriminant, so I can see how many solutions this have and if I need to keep going. So I'm going to identify that my A is 1, that B is 9, and that C is 15. And then when I do my discriminant, B squared minus 4AC, I'm going to have 9 squared minus 4 times 1 times C. And let's see, that's going to give me 81 minus 60, which is going to give me 21. So positive discriminant tells me that there's two solutions. So I'm going to need to continue with the problem with the quadratic formula. And so now I'm substituting into here. I'm going to say x is equal to the opposite of b, negative 9, plus or minus the square root of the discriminant, which I found was 21, over 2 times a, and a is 1, so my answer is 2. Now, that's my answer in radical form, or my exact answer. If I need to, I can get a decimal equivalent, but for right now, this is perfectly fine to leave our answer in this format. Right, if we go to look at our next one is x squared plus x minus 20. And so if we look at this one, if we want to try set equal to 0, if we first want to try factoring, we could do that and say that if we need a negative 20, well, that could be 1 and 20. One of those would have to be negative. I'm looking for a positive x here, so that didn't work. I could have a 4 times a 5. If I have negative 4 times 5, that would give me a positive 1. So there's my correct combination. Now, if you want to go through the whole box of factoring, you can. Okay, so that's a previous skill that we're using here. You do what you need to do to get that factoring correct. So now we're going to take and factor this and say that this is x minus 4 and x plus 5. Once we factor it, we use the zero product property, and I set this equal to 0 and this equal to 0. And I would end up with 4 and negative 5. Okay. Now, I want to show you that, let's say that you forgot about factoring, or you looked at it and said, nah, I'm not real sure if it factors. I'm immediately just going to go and try the quadratic formula. And so that would mean that A is 1, B is 1, and C is negative 20. And so if we started with the discriminant, we would have 1 squared minus 4 times A times C. And we would end up with 81 as the discriminant. Now, that positive 81 tells me two things. It tells me there's going to be two solutions, and so I need to keep working the quadratic formula. The other thing it tells me is, since it is a perfect square, that this problem does indeed factor. Now, at this point, you would have a choice. You might say, oh, let me go back and see if I can factor it. Or you would just continue on with the quadratic formula and say that x is equal to the opposite of b. B is 1, so that would be negative 1, plus or minus the square root of 81 divided by 2 times a. A is 1, so that's 2. Now what happens here is we have the square root of 81, which is a perfect square, which gives us 9. So that would mean that x is equal to negative 1 plus or minus 9 divided by 2. Well, if we think about this now, we would have negative 1 plus 9 divided by 2. That's going to give us 8 divided by 2, which is 4. Which was one of our answers right there. If we do x is equal to negative 1 minus 9 divided by 2, here's negative 10 divided by 2. That gives us a negative 5. That was our other answer there. Notice that we got the same answer whether we did the problem by factoring or by the quadratic formula. And so this is really where your strength comes into play in this lesson. All three of these methods we've learned and spent time on. We've practiced individual weeks on square root, on factoring and quadratic formula. So there's not a new method this week, but where the challenge is you figuring out how you want to start the problem.